Now we'll study the flotation. So let's understand the concept first. Now we have seen some cases if there is a liquid and if I dip some body in the liquid, sometimes we observe that body goes down completely. But sometimes we observe that these bodies don't go down, they remain floating. They remain up. Some portion of the body remain down of the liquid, inside the liquid, and some remain up in the air. So what is it which is causing some bodies to go down and some bodies to remain float? What is it? So that's what we want to study in this. So what happens ultimately if the body is going down or it is stationary, it is floating, the cause lies in the forces. So we have to study the forces, what kind of forces which are acting onto the bodies. So let's study this in this case. So if I talk about this body, there are two types of forces which are acting onto this body. First is the mg, which is acting onto the body, the weight. And the second force is the pressure force. There is a pressure force acting onto the body due to the liquid as well as due to the air. So these are the two types of forces which are acting onto the body. And the resultant of these two forces will decide what is going to happen with this body, whether it is going to float or it is going to go down. So let's talk about first. So if this is the body, then there will be mg acting onto the body. And that mg will be acting at the center of mass of the body. Okay? This is one force. And the second force will be the buoyant force. Because see, we don't want to study the pressure force if we can study we can get the buoyant force. The buoyant force is nothing but the resultant of pressure force which is acting onto the body. So resultant of pressure force, if you think about, which will be acting onto the body, that is called buoyant force, that will be acting at just below this mg somewhere. So I'm showing this Fb. So Fb will be acting up and the mg will be acting down. So now you can see if the mg is more than Fb, this body will go down. And if Fb is equals to mg onto this body, that body will float. And if Fb is more than mg, this body will fly, which we never see. So it is not going to happen. So out of these two forces, mg and Fb, mg is constant. It is not going to change till you change the body. But this Fb, if you think about, this Fb can change. The Fb depends upon the volume or weight of displaced volume. So if the body is up, in this case displaced volume will be a little bit less, in this case displaced volume will be more. So value of Fb will be changing depending upon the volume. Okay. So now let's define some things here. So what I'm doing, I'm defining the density of liquid as rho L. I'm defining the density of body as rho S. S stands for solid. I'm defining the total volume as V T. This is the total volume of the body. I'm defining displaced volume as Vd. D stands for displaced. Okay. So, and obviously G will be acting downward. There's G which is acting downward. So let's one by one calculate the value of mg and Fb. So if you calculate the value of mg in terms of volume and density, the mg will be equals to volume of the total volume of the body multiplied with density of the body, which is rho s, and multiplied with g obviously. This is the mg which is acting downward. Let's call it equation 1. Now let's calculate the Fb. So Fb is equals to displaced volume Vd. Obviously this displaced volume will always be less than Vt, multiplied with density of the fluid multiplied with G. This is my equation 2. This force will be acting up and this force will be acting downward. If I make the FBD, or we don't need to make the FBD, we can just see these cases. So cases we can make. So case 1. If you think about the case 1, I'll say the case 1 is this, when the body is going down. So in the case 1, this mg has to be more than Fb. So if mg is more than Fb, the body will go down. It will go down. So let's think about the cases here. Let's put the values here. So for that to happen, Vt multiplied with rho s multiplied with g will be more than Vd multiplied with rho l multiplied with g. Or you can say rho s is more than Vd upon V total rho l. So if that's the case, if mg is more than Fb, the thing is rho s is more than this value, that this this displaced volume, the maximum value of displaced volume can be Vt. So if I want to calculate the critical value of density, solid density, so to calculate rho s critical, meaning when the body is actually going down. So to calculate the critical value, the Vd will become Vt. The displaced volume will become the total volume, because when the body is body will be going down, the displaced volume will be equal to the total volume. So if that to happen, the density rho s, that will happen in case of this. So whenever the density of the solid is going to be more than the density of the liquid, the body cannot float. Body will always go down, if that's the case. And there is a minor point here. In this case, we are assuming there is no cavity inside the body. We'll do some questions where we'll see those kind of questions, those kind of cases where when there will be some cavity inside the body, and that will make that in that case the body will still float, even if the density of the solid is more than the density of liquid. We'll see those cases. So, but apart from those cases when there is no cavity, when there is a solid body, if the density of the solid is more than the density of the liquid, body is going to dip inside. It can never float there. Okay, so this is the case 1. Now let's go for the case 2, when the body is actually floating. That's the case. Case 2. This is the case of flotation. So when the body will float, Fb is going to be equals to mg. So when the Fb is equals to mg, let's put the values. So Vd, displaced volume, rho L multiplied with g will be equals to total volume multiplied with rho s multiplied with g. Or we can say Vd upon V total will be equals to rho s upon rho L. Since you know this Vd will always be less than V total, the displaced volume. If the body is floating, the displaced volume will always be less than the total volume. That much is sure. So if the Vd is less than V total, or we can say Vd upon V total is less than 1. So we can say the rho s will be less than rho L. So this is the condition to float. So whenever the density of the solid is less than the density of the liquid, in that case body will be floating. And when the body will be floating, some of the volume of the body will be up the surface and some of the volume of the body will be down the surface, and we can make the relationship out of that. The Vd, this dipped volume divided by total volume will be equals to rho s upon rho L. It will decide the ratio.